This video is going to talk about how to calculate with measurements and how to answer in the correct number of sig figs. So the rule basically is that your answer can only be as precise as your least precise tool. So we have these rules for what your answer is allowed to be based on the precision of each of your tools. So we'll start with addition and subtraction. So in addition and subtraction, your answer reflects the fewest number of decimal places as seen in the problem. Okay, so what does that mean? So I'm going to look at this problem over here, and in this case, all I'm looking at is how many places after the decimal does each number have. So in this problem, I have 19.0, so that's one place after the decimal. And then I measured something to be 101.10 grams, so that was clearly on a better scale. And I've got two places after the decimal. And my last measurement must have been on a super precise scale because it measured something at 0.675 grams. So I used three different scales here for some reason. And this number has three places after the decimal. Well, once you add it all up in your calculator, you get 120.775 grams. Now, here's the problem. Your very first scale was not very precise. And so that measurement is only good to the tenths place. That means that these numbers that are beyond the tenths place are sort of meaningless once you get your answer. So these last two digits don't have very much meaning because your first scale, the guess digit was in the tenths place. So there are no digits here, right? They didn't measure any of these. They have no idea what these numbers are. So if you add them all together, your answer is only allowed to be as precise as your least precise measurement, which was that first one. So that means that you have to round to the tenths place, to only one place after the decimal. So when you round, you use regular rounding rules. So if your number to the right is 0 to 4, you do not round up. If it is 5 to 9, you do round up. So those are just general rounding rules like the regular ones from math. So in this case, my number to the right is 7. That means that my number gets rounded up. So I go from 120.7 to 120.8 grams. So again, the rule is your answer can only be as precise as your least precise tool. The second type of calculation is multiplication and division, and they have their own rules for sig figs. So in this case, we're no longer looking necessarily at just the decimal. We're going to look at the number of sig figs that are present. So the answer reflects the fewest number of total sig figs as seen in the problem. So let's look at this particular problem. I've got 2.54 centimeters. I've got times 2.5 centimeters. I must be doing volume here. And then times 1.975 centimeters. So once again, as a scientist, I've decided to use three different types of rulers. I used a ruler that was not that precise, and then one that was a little bit more precise, and then one that was a bunch more precise. So each of these have a different number of sig figs, and this number in the middle only has 2 sig figs. That's the fewest number of sig figs present in my problem. That means my answer is also only going to be allowed 2 sig figs. So what I'm going to do is I'm going to calculate it out. So I put it in my calculator and I get 12.54125 centimeters cubed. Well, I only get 2 sig figs. So I'm going to get this digit and I'm going to get this digit. And I'm not going to get any more digits. But before I'm done, I have to look at that number to the right. Since it's 5, that means that I'm going to round my answer up. So instead of being 12, my answer is going to be 13 centimeters cubed. Why centimeters cubed, you asked? Oh, what an excellent question. And I've said this before, but just so that you have it down in your notes, units will behave like math variables. So if you have x times x times x, that's x cubed. So that means that if you have centimeters times centimeters times centimeters, that's going to be centimeters cubed. If you have x squared times x over xy, then it's going to end up being x squared over y. So, I don't know, let's do, what if you have seconds squared times seconds over seconds, I don't know, times meters? Well, then the seconds and the seconds will cancel, and you'll be left in the units of seconds squared per meter, which I don't think is a real thing. But that's how units work. So they behave like math variables, which is actually important above as well, because you can do centimeters plus centimeters, so you can add like units, but you can't add units or subtract units that are not the same. So you cannot do x minus y, just like you can't do grams minus centimeters. So that's a little bit about how we calculate using sig figs.